Over the menu a week from today, we're going to have a full quiz. Going through the last day of class will be an objective time. There will be 4 problems on it. You won't get to it. Be over auxiliary use. Alright, tonight I'd like for you to have or gain some experience on how to develop fasteners. They're known as threads. As we both know, there are several different types of threads. There's the coarse, the fine. There's those that you can spin a little nut on, otherwise, and there's those type of threads that square, accurate. Anyway, you as an engineer out there in the real world are going to be designing threads or fasteners, the whole pieces of metal together. And this plate that you're looking at right now, there are 2 problems on it. And notice also that there is metal being brought together. You cut into it. And it's kind of a sectional view of a nut, a bolt on the head. And that's what you're going to develop here in a few minutes. Now, there are types of threads that you're going to be running into out there in the real world. And the first one is, treat this as a step right here. And there'll be a dotted line right there, and that's what we call a simplified thread. And you may see that quite often. If there is no need to show the actual, I call it detailed threads, which I will go in a minute, you'll probably see this. Or you may be looking at a type of thread that all it is you got long and short lines representing the thread. And that's called schematic. S-C-H-A-M-A-T-I-C. And this is simple as saying P-R-C-F-I-E-D. And the one that we're going to be drawing here tonight is like so. Detail. Now, on the computer, you may design a type of thread, detail thread, and you may want so many threads per inch. All you have to do is design one thread, punch a command or 2, and bingo, you've got all the threads instantly. And that's the beauty of that computer. Have you got into that yet? You haven't made any threads or anything on the computer. By the way, we only have 6 more meetings, and this semester is over with. And 2 of these meetings are going to be dealt with tests. And then I'd like for you to look at 12-1 next time. And while you're in chapter 13 on threads, you might want to start looking on 12-1 and filling in there. But we'll talk a little bit more about that the next time we meet. Okay? Now, while we're back here on this detailed thread, the peak of one thread to the peak of another thread is called the pitch. That's the distance that the thread or the nut on the thread will travel on a 360-degree turn. Okay? If that happens to be an 1/8 in here, or 3.5, or whatever, there. That's the distance that thread will let the nut travel, or the bolt itself travel, whichever way the thread goes. Okay? All right, now let's look at these two problems that we're going to look at tonight. We'll walk you through both of them. The first one up here, it has to do with a square head bolt and nut. The second one has to do with a hexagon head bolt and nut. And I want you to put right-hand threads on it. And I'm going to show you how to do that up here on the board. Now there are the pages you might want to really look at on chapter 13. And thread notes will be on page 373, 374. Now how you make those threads is on page 368. On 382, page 382, we'll walk you through on both of these columns right here. I'm going to walk you through. Then you're going to use steady carol. You got that outline to follow. And you should have a good place to be turned in next time we meet. Okay, so here we go. The first one here, you are to draw 7/8 diameter. Now when you go down here to the hardware store and get yourself a nut bolt, that's the first thing you're concerned with is the diameter of it. And the next thing you might be concerned with is the type of thread, or any thread, excuse me. And this one wants 9 threads per inch. And you got 2 inches of them, so how many threads are you going to have? 18. All right. And it's United National Coarse. And you might see it in United National Fine. You might run into that. And then there's a class, a fifth, which is 2. Otherwise, that's loose. You can take your nut and put it on there with your fingers. Now, there are other classes, 1, 2, 3, and 4. 1 being where you can actually spin the nut on the threads. And like I said, 2 is the most common one. For instance, the hasp on that back cabinet and that one back there, I used a class 2 fit, otherwise they're loose. Now 3 is probably like the nuts and bolts on your car. They don't come loose very quickly. Or on your skateboard or bicycle, whatever you want to travel. Now 4 is a high tolerance. Otherwise, the nuts and bolts in your watch is probably a high tolerance type of thread to hold those gears in place while you're getting time with it. And the next thing we want to have here is the length. And this one is 3 3/4, and you measure the length of your bolt from underneath the head to the end of it. Now, if you will, put RH. I want right-hand threads. And I'll show you how to develop the right-hand threads in a minute. Okay? All right, to start out with, we've got to draw a circle. And we've got a formula to go by. 1 1/2 times the diameter. And I want a heavy duty. Otherwise, it's going to be the thickness of the head. If you go down here to the hardware store, it's going to be 2/3 of the diameter of the bolt. That's how thick the head's going to be. And the nut usually runs the same as the diameter of the bolt, the thickness of it. If you will, if you want to use, like it shows you in the book, 2/3, that's the normal that you go down to the hardware store and get. But if you got a special order, you can use the diameter of the bolt for the thickness of your head. And then here, I'd like for you to do that too, okay? But if you, either one, I'll accept either one. And I'll show you that in just a minute. Heavy duty. We want to really hold those pieces of metal together. And I want that head and I want that nut flush up against those two pieces of metal in each pommel. Okay? 1 1/2 times the diameter. Well, 1/2 that's 7/8. And half of that is going to be 7/16 because I converted that into 14/16. And 1/8 is 2/8, 2/16. I'll get to it in a minute. And 2 9, that's 23/16. That's equal to 1 7/16. That's the diameter of that circle. Okay, there's my 1 7/8 circle right there. 7/16. Okay. Now the next thing, take your 45 and draw a square around it.